Hello, everyone. My name is Kelly Antoniadou, and I am a PhD student at Chalmers University in the Division of Electric Power Engineering. In this video, I'm going to present to you my research on optimal operation of grid-connected microgrids. Now, before I start the presentation and we go a little bit deep into what microgrids are, I would like you first to try and answer this question. Where will your electric energy come from? I know it is quite generic, but what comes first to your mind? Probably most of you are thinking about the sources of energy, be it fossil fuels or solar irradiation, wind. Did any of you think about the location of these energy sources? The location is important because it affects the design of our electric energy system, and the design affects its operation. And the location of the energy sources is what motivated my research in the first place, as you will see shortly. But first, let's see how this works. Let's see how our electric energy system is able to generate, transfer, and distribute electrical energy down to each of our homes. Up until now, the electric system was designed to transfer big amounts of generated power through a long distance to the consumers in cities or rural areas. Take Sweden, for example, as you see in this map. Most people live in the south. However, there are huge amounts of hydropower in the north. Therefore, we had to construct an extensive electricity grid in between to transfer all these amounts of generated power to cities which are far away. And there you have the electric power system: generation, electricity grid, and consumption, where the electricity grid is divided into the transmission system, as it is illustrated in here, and the distribution system, where the grid is divided further into electricity lines that transfer smaller amounts of energy to each of the homes here, to each electricity customers. But things have been changing with the installation of local renewable energy sources, which is promoted by energy policies that aim to fight the climate change. Sweden in particular has set very ambitious energy goals of 100% renewables by 2040 and carbon neutrality by 2045, which means that the amounts of greenhouse gases that are emitted to the atmosphere, they must be balanced by the absorption of these gases by the atmosphere. So thanks to these changes, in the 6 generations of humans that have been consuming electric energy, never before has such a large amount of our consumed electric energy been produced so close to the consumption points. So this electric power system that used to be controlled as one entity is being divided into sub-areas that are like miniatures of the old system. So we just cut the long distance between generation and consumption. These areas, they are called microgrids, and this is what my research is about. Their name, microgrid, indicates the contrast between the main distribution grid, which is the big grid, and I specifically focused on grid-connected microgrids because there are microgrids that can operate without having a connection to the main grid. So what I do in my research, I try to address questions such as how can we best operate the systems? Because sure, they look a lot like the old system, but they are also very different. They are usually supplied by energy that we cannot control, like solar energy. So what can we do? Maybe we can use a battery to store our excess production and use this energy later when the sun will no longer provide this energy for us. Maybe if we cannot control fully our generation, maybe we can control our consumption. Most likely in the future, you as consumers will have to help with that, but don't be frightened when you hear about control of consumption, because that will be done automatically with smart devices that can, for example, postpone the laundry for 15 minutes or stop charging your electric car for the next 50 minutes, as long as you, the consumer, of course, are okay with it. You might even control these smart devices through an app in your phone, and maybe you will get a notification saying, if you reduce your consumption by this amount, you will gain this amount of money. Okay, but now that we have a clear vision of the future electric power system and what role the microgrids can play into it, let's talk more about what a microgrid is and what it can achieve. A basic microgrid consists of solar panels, plus some energy storage, like some large stationary batteries, and of course the buildings with electricity consumers. The electricity demand of the buildings, it can be supplied either by the local renewables or through the main grid. More advanced microgrids can control other controllable resources, such as electric cars and smart devices that will control the consumption of active, or as we say, flexible consumers. The brain of the microgrid is the microgrid controller, which is the controller is responsible for a number of functions and operations of the microgrid. One of these operations, which is called energy management, is performed by a part of the controller, which is called energy management system. And I specifically focused on this operation. So energy management is the control of the energy generated or consumed by the local resources, which is, that includes also the charging and discharging of the batteries. And through the control of the local resources, we control the energy exchange with the main grid. So this is energy management. The operation of the energy management system is determined by the energy management model that is integrated in it. So for my research, I developed and tested such models that could perform optimal energy management, meaning that they could improve the operation of the energy management system. Okay, so what have I been trying to achieve by developing these models of optimal energy management? With these models, we can reduce the cost of electricity for the microgrid customers, the people that reside in the buildings. This can be achieved by reducing the amount of energy that we import because we have local generation, or it can be achieved by selling our own generated energy, which is exported to the grid, to the main grid. We can also take advantage of the difference in electricity prices at different hours of the day and reduce our costs by consuming larger amounts when the prices are low and selling big amounts of energy when the prices are high. The energy management system can also cooperate with the utility that operates the main grid and assist in a more safe and economic operation of the main grid. For example, to avoid having a too high consumption at one local area in the big grid at a specific time within the day, let's call it the rush hour, the utility can request from the microgrid that can control its resources to export more energy to the main grid. Finally, with optimal energy management, we can prolong the lifetime of the assets. And we can also postpone the investments for upgrading these assets or the grid infrastructure. So we end up using the same assets and infrastructure for a longer period of time, and thus contribute to increasing the sustainability of the electricity grid. And just to show you that research on microgrids is already very relevant for practical applications, today there are almost 8,000 microgrids projects globally. 11% of them are in Europe, and in Sweden, the first local energy system that can be characterized as a microgrid is found in the Simris village. In my research project, I tested some of my energy management models and solutions in testbeds developed in real-life environments such as the Chalmers University campus and 2 residential buildings that represented microgrid systems. All 3 test sites, they had installed solar panels for local generation of electricity and stationary battery systems. You see this battery in here, and you see these are second life batteries which were taken from all electric buses. So I demonstrated the effectiveness of my research solutions by controlling the power consumption of the microgrids through control of the batteries. And all this was done by my computer while I was sitting in my office, since my computer performed the operations of the energy management system. So we're almost done with the presentation. And if you're going to keep 3 things out of this regarding the grid-connected microgrids, that would be the development of the microgrids is supported by the increased integration of local renewables. So we have a lot of generation closer to consumption. And if we combine this local generation with some energy storage and some intelligent control like the energy management system, well, we have the basic microgrid system. Another thing to remember is that the electricity consumers will get more actively engaged in energy management. They will be a very active part of the energy management of the grid. And lastly, the optimal energy management models improve the operation of the microgrid and reduce the costs of the microgrid electricity customers. So there are economic benefits in here. For example, my case study showed that my proposed model, which was applied at the HSP living lab building that I showed before, could reduce the total cost for the customers by 3%. So think about it. The energy you consume might be produced very close to you in the near future. And you, as a consumer, might have a very active role in supporting an economic and sustainable operation of the electricity system. So that was the end of my presentation. And thank you very much for staying with me until the end. I would appreciate it if you could spend a few minutes of your time to give me feedback on this presentation. You will find a link in the description below the video to the form where you can give me the feedback. And you can also, if you have any questions regarding this presentation, you can send them to me through email, or you can just type in your comment below. You can also learn more about my research by looking up my name in the Chalmers database in here. All these links in here, they will also be available in the description below the video. So once again, thank you for being here. Bye-bye.